Hello, and welcome to the Data Engineering Podcast, the show about modern data management. Data migrations are brutal. They drag on for months, sometimes years, burning through resources and crushing team morale. Datafold's AI-powered migration agent changes all that. Their unique combination of AI code translation and automated data validation has helped companies complete migrations up to 10 times faster than manual approaches. And they're so confident in their solution, they'll actually guarantee your timeline in writing. Ready to turn your year-long migration into weeks? Visit dataengineeringpodcast.com/datafolds today for the details. Your host is Tobias Macy, and today I'm interviewing Pete DeJoy about building and managing Airflow pipelines on Astronomer and the upcoming improvements in Airflow 3. So, Pete, can you start by introducing yourself?
Yeah, absolutely. Thanks for having me on, Tobias. My name is Pete. I'm one of the co-founders and I lead product at Astronomer. I've been working on Airflow and kind of Airflow adjacent technology for the better part of the last decade, primarily focused on one, building the open source project Airflow and working with a very talented team who's really driving that forward. And two, building commercial products to help with managing Airflow and running Airflow at meaningful levels of scale, and now kind of extending into a broader kind of data ops platform that we're working on. Astronomer's been around since 2018, really focused on, again, all things Airflow, driving the project and community forward. And it's been a real joy to work with such a vibrant open source community and project and see all the progress that's been made. So,
And do you remember how you first got started working in data?
yeah, so actually, like prior to Astronomer being the Airflow company, we were working as kind of a data services company focused on a bunch of different things. This was kind of back in 2015, 2016, doing services projects for a bunch of customers. And we got to know Maxime very well early on, working with Airflow. He had written Airflow at Airbnb and open sourced it in 2014, 2015. And we became kind of in-house Airflow pros because we were writing all of these data pipelines on behalf of our customers. And as a result, we got to know the ins and outs of the project very well, and it was time for Maxime to go start working on his newer project, Superset. We had a discussion with him and really stepped in to continue driving the Airflow project forward, and that's when we kind of rebranded the company to really focus on Airflow and refocused everything that we did around Airflow. So yeah, we were kind of doing data services work for a long time before we even got our hands on just running Airflow for a bunch of customers at scale.
As you mentioned, Airflow and Astronomer have grown to be very closely linked by virtue of the fact that that's where you're spending a lot of your time. Obviously, Airflow is an Apache project, so there's no one company that controls it. But so I'm interested in how you would characterize the relationship that you have between Airflow, the open source project, and Astronomer, the company, and the role that you play in that community.
Yeah, it's a great question. There are like so many different ways to build open source businesses. You look at companies like MongoDB that really maintain control of their licensing strategy. But then you also look at companies like Databricks and Confluent with Spark and Kafka, really building businesses around Apache projects. We fall into the latter bucket, obviously focusing on an Apache Foundation project and building kind of the commercial abstractions around it. We really do drive every major Airflow release. We have 18 of the top 25 committers to the project and 8 PMC members on the Astronomer payroll. We've contributed at this point about 60% of all Airflow code just in the repository. And yeah, we have a ton of Airflow expertise in-house. So generally, a lot of our business is centered around folks that are running Airflow for very critical workloads. And, we have a very deep bench of folks that know all of the ins and outs of the Airflow code base and can help out. So, yeah, as with anything, we don't like to use the word owner. That feels a little bit disingenuous given that the project is an Apache project, but we certainly feel a great obligation to the community to making sure that the project maintains its vibrancy and health and that we're building for the next generation of kind of developer and data engineering abstractions in the open source. So we certainly feel accountable for the outcome of Airflow. Maybe that's the best way to position our relationship with the open source project. Like we very much have a deep vested interest in its success. So.
Because of the fact that Airflow is one of the early movers in whichever generation of data orchestration we're in at this point, it has long become the target for any subsequent projects that have come along. I'm thinking most notably of Dagster and Prefect that use Airflow as sort of their boogeyman to draw comparisons against. And so I know that also Airflow itself has not remained static. There have been a number of iterations, and one of the things we'll talk about today is the upcoming version 3 release. And so I'm wondering if you can give your sense of the position of Airflow in the ecosystem, some of the lessons that it has learned from its competitors, and some of the inspirations that it has provided to the overall data ecosystem?
Yeah, that's a really great question, Tobias. Look, I think we're always just kind of focused on Airflow's success. We try not to spend too much time worrying about what the other folks are doing. Candidly, like so much of our business and our focus is just in growing the Airflow market and making sure that we're servicing that market with commercial products that add value. But all signs for us and all of our engagement with the community says that Airflow is only continuing to get more popular over time and that the community is just continuing to grow. We actually just released our Airflow kind of state of Airflow 2025 report yesterday. We had over 5,000 respondents. It was a 5x in terms of just pure volume as last year's survey. And we just are seeing a lot of adoption in the community. Download counts continue to go up and to the right. I'm fairly certain we had about 32 million downloads on PyPy in the month of December, kind of closing out the year. And that's up from a much smaller number several years ago. I don't want to cite something wrong here. But you can go kind of look at the PyPy stats yourself and draw your own conclusions. Airflow is also the most contributed to Apache project of all time at this point. It has the most contributors just from a pure kind of GitHub contribution perspective. So the community is still incredibly vibrant. And as we look at Airflow 3 and think about the next generation of Airflow, we certainly do look at really what is required to continue supporting the needs of data engineers, things like better data awareness, better abstractions for event-driven architectures and scheduling. And that really motivates the way we think about driving the future of the project. But again, like that really is done in tandem with our customers and our community members, more so just focused on solving their problems, not so much focused on kind of competitive pressures or decisions.
I also forget exactly what the number is, but Airflow came out a number of years ago at this point. If it hasn't already reached it, it's going to be pushing a decade. And obviously, the overall data ecosystem has changed dramatically since then, especially in the past year or two with the introduction of generative AI and all of the new data infrastructure requirements that brings with it. And so I'm interested in understanding the ways that Airflow itself has grown and evolved to account for the underlying shifts in the ecosystem that it is put into the center of to manage the actual health and well-being of those different platforms and the infrastructure and systems that they support.
And when you say different platforms, are you specifically referring to kind of generative AI platforms and applications?
No, just generally speaking, the data platforms that businesses are building and using Airflow to maintain the health and well-being of making sure that all the data goes where it's supposed to go.
So it's funny you bring that up, Tobias, because we've seen this like very, very interesting trend. I've been working with Airflow for almost 10 years now. And, I think you're right. It has been a decade of Airflow at this point. When we first started engaging with data engineers in the Airflow community, a lot of the discussions we were having were about analytics. It was really about how do I write a data pipeline that, does some kind of data transfer from one of my SaaS APIs into my data warehouse so I can build a dashboard of some kind, like very internal reporting heavy. We've seen this trend kind of more broadly over the last several years where a lot of data infrastructure is now powering more critical stuff for these customers than internal reporting dashboards. Not to say internal reporting dashboards are not important. I use them every day in my job at Astronomer. But we're talking tables that are embedded in applications for end users to consume, such that if the Airflow pipeline goes down, there's like a product customer-facing SLA breach, or things like regulatory reporting for highly regulated industries like sports betting, gambling, gaming, banking, financial services, etc. Things like training machine learning models and all of the kind of operationalization of the training process. These are the types of things that we see people increasingly leaning into Airflow for. And as a result, the position of Airflow and orchestration has just become much more critical. So like kind of this whole focus on reliability and the connection to this broader data platform has gone up in the last several years. And we've really felt that pressure from our customers. We have this kind of joke that we say internally, it's not, we certainly are kind of a P0 service for all of our commercial customers. If people are working with us, it's often because they're running Airflow for some very critical process that is important to them, meaning like if Airflow goes down or if Astronomer goes down, there's a really, really big problem. That's not a privilege we take lightly. So primarily for us, this whole trend moving from analytics into operational data products has been really interesting to see because it's just increased the criticality of data engineering workloads and the work that data engineers are doing every day. Now, that trend is obviously fueled even more by the rise of generative AI. Now everybody is trying to build something with generative AI and leveraging their domain-specific data to have some level of competitive advantage, even without like getting to fine tuning or actually doing anything fancy or on top of foundation models besides pure retrieval on documents that are proprietary to the company. And we see Airflow community members really leaning into Airflow as the batch orchestrator of choice for these Gen AI workloads. Airflow is already kind of battle tested and proven for these types of batch oriented workloads. So when it comes to things like chunking and embedding documents and loading them into a vector database for some RAG application, Airflow is the standard and it's the default. When it comes to doing things like batch inference, summarizing sales calls was one that one of our customers mentioned earlier this week. They process all the transcripts of their sales calls and send an executive summary every week via an Airflow DAG that effectively, pulls in all that data, it calls the LLM, and then produces the result and sends an email to all the executive team letting them know what trends they should be looking at in their sales calls. This is kind of an entirely new category of workload that is, again, just increasing that focus on Airflow and on that data platform. So it's a very exciting time to be engaging with this community, and something that we're very focused on in Airflow 3 and beyond, building the right kind of abstractions to support more of that.
Now, digging into the Airflow 3 release, obviously major version numbers signify some significant amount of change. We've just discussed some of the ways that the underlying data ecosystem is changing around it. So wondering if you can give some of the main takeaways of what you've learned over the course of the version 2 lifecycle and some of the key capabilities that you're looking to introduce with version 3.
Yeah, no, it's a great question. So I think people kind of fell in love with Airflow because of its simplicity, this kind of deterministically oriented way of defining workloads, right? It was like very, very process oriented. Naturally, one of the big pressure points in the community was to add more data awareness, i.e., connect that deterministic process oriented workflow to the actual tables and assets that are being manipulated by those processes. So a lot of the focus on Airflow 3 for those use cases was really centered around bringing some level of data awareness into the core orchestration engine and introducing the concept of assets into Airflow and everything going on there. Additionally, we've made some significant architectural improvements to decouple the task execution interface from the core orchestration engine. That's allowed us to do two really interesting things. One is actually run kind of remote workers for customers rather than closely coupling the workers with the scheduling layer. You can have a lot of flexibility in your compute layer. So orchestration generally sits as one control plane on top of a very highly distributed computing environment. And many of our customers and community members want to be able to schedule across AWS EC2 instances, across servers they have running on premises, a Kubernetes cluster that they're rolling out on OpenShift. And this level of flexibility and optionality allows customers to find that perfect balance between convenience and cost and security so that they can plug in more flavors of enterprise workloads into the Airflow engine. The third category of thing is we're able to actually introduce multi-language support at this point. Airflow has always been very Pythonic. And by decoupling this task execution interface from the core orchestration engine, we're able to build SDKs for languages like Go, TypeScript, Java, and that's going to be a big focus of ours over time. So, again, a lot of the way we think about this is Airflow at its core is a really incredible batch orchestration engine. It is running some of the most critical workloads in the world for some of the biggest companies in the world at this point. So it does have those miles at kind of the enterprise scale testing end of the market. And what we really want to do is make it such that more flavors of workload can be deployed to that engine. And that's simultaneously a technology problem, but it's also really an interface problem. Like developers need to be met with the right SDKs and abstractions that they're comfortable with. We don't want to go to like a new persona and say, hey, you must now learn how to write Python and how to know the Airflow DSL if you want to actually like schedule some interdependent processes together. So we want to make it much more accessible for a broader audience of people.
To that point of the audience and the growth of the number of people who are interfacing with it, data engineering has become a very diffuse responsibility where for a while it was the DBA became the data engineer. It was, largely a change in title, but not a change in role. As data has become more operationally significant and found its way into consumer-facing applications and every other aspect of business, the responsibility for data has become more than just the DBA or the
Absolutely.
data warehouse engineer or the business intelligence engineer. So to that point of meeting people where they are, how are you seeing that persona of who's actually building with and for Airflow evolving as we grow the number of people who are responsible for the data in an organization?
Yeah, so there's just like one of our gospels at Astronomer that we share with like all of our new hires was this post that Maxime wrote, I think in 2017, called The Rise of the Data Engineer. I know like kind of data engineers have been around for a long time, but that was kind of his classification of what the new kind of cloud native data engineering profession really looked like. And he defined, hey, data engineers historically lived in these vertically integrated ecosystems and did a bunch of kind of WYSIWYG drag and drop work. Data engineers are now looking much more like software engineers, where they're defining their data pipelines and processes as code. They're version controlling those assets in the same way that they version control their software applications. And I do think that was like a very big shift in the industry. Data engineering really moved into this world that looked much more like software engineering. And that I think that definitely took off. Like early days at the company, we spent a couple of years like convincing people that kind of pipelines as code and data engineering as software engineering was the right way. We no longer had to kind of sell that future pretty quickly because a bunch of people really leaned into it. Now, the way we've seen the data engineering and kind of core data platform profession evolve over the last couple of years, Tobias, is what we found is as data engineering centers have really built this center of expertise and excellence in the data platform at large, they really have become the bottleneck to production for a lot of different kinds of data workloads inside of the four walls of a company. So many, as data has become more strategic, everybody wants to get involved with AI or more deep advanced analytics projects. There are many different kind of stakeholders in the data ecosystem in the company than there were 10 years ago. You have this whole kind of category of analytics engineers that are largely living in the world of DBT. You have data scientists and machine learning engineers who are living in Jupyter notebooks and R and kind of scripts running on cron locally. You have a bunch of folks really focused on data ingestion and management. And then you have a bunch of folks who are actually much more comfortable living in kind of lower code interfaces that might be programming DAGs, but in something like Zapier or some other kind of more accessible consumer oriented workflow tool. And what we found is as the needs of those downstream stakeholders teams have evolved, the data engineering team tends to be the control point between them and kind of the production infrastructure. So generally, if the data engineering team is the one responsible for productionizing DAGs, what ends up happening is they have an analytics engineering team throwing DBT models over the wall to them and saying, hey, I need to run this model every night at midnight so that my tables are fresh in the morning. And then it's on the data engineering team to really reason about, okay, how do I take this DBT job, turn it into an Airflow DAG, put it in production so that it actually is part of our core production scheduling system. Same thing with like a Jupyter notebook. A data scientist might say, hey, here's a notebook. I just need it to run every night. Schedule it for me. Now, the data engineering team knows that like scheduling notebooks arbitrarily in production is usually a pretty bad idea. So they do a bunch of work to translate that notebook code into something that's a little bit more rational and putting it into that production engine. And as a result, a lot of data engineering teams are like totally underwater and inundated with tickets because they're servicing all of these other internal stakeholder teams. And that actually like stops them from doing more strategic high leverage work for the business. So when we think about the next kind of wave of data engineering, this is obviously going to be assisted by large language models and the productivity improvements that we can see in just data and software engineering workflows with the embedding of LLMs. We want to make data engineers an enabler and stop them from being a bottleneck. So allow those teams to all self-service that core orchestration engine, whether it's via developer abstractions for DBT. We have a library called Cosmos that we released that actually solved this problem in spades, and we saw a lot of viral adoption in, whether it's meeting the data scientists and machine learning engineers where they are, or whether it's meeting any of those other downstream personas where they are. So the data engineering team can set guardrails, but not actually be standing in that path to production as they are today. And we very much view that as kind of the highest value thing that we can do for data engineering communities these days, and it's where we would like to take that profession and persona. And I think it really is posing an exciting opportunity. So this is something that we talk to all the time about our customers because often we're working with that core data engineering team, and they'll call us up and say, hey, I can't free myself up to do higher leverage work because I'm so underwater with productionizing work from we even have a term for it, OPC, other people's code, and I want to go do more strategic work. So that's a big focus of ours.
one of the constant burdens for data engineers in a number of situations also is the fact that they are responsible for the underlying infrastructure that their pipelines are executing on. So there's a wide swath of the stack that they have to be familiar with to be effective. So they need to be able to understand how their VM's working or how Kubernetes operates, how to deploy the Airflow and the associated DAGs, the different other pieces of infrastructure that they're managing, maybe the data warehouse. And to your point, that can consume a lot of attention and time that could otherwise be spent on more high leverage use cases, which is where your Astro project comes in, where you try to abstract away more of that infrastructure management to let them focus just on this is the piece that you care about, these are the DAGs, these are the data flows, this is what you actually want to be doing with your time, not figuring out why the TCP stack in your Kubernetes cluster is crashing or whatever the weird obscure bug is that they might be running into. So I'm wondering if you can talk to some of the ways that you think about how much of that to abstract away while also maintaining some of the escape hatches for the case where that engineer really does need to go down to, tuning kernel parameters to optimize throughput or whatever it might be.
Yeah, it's so like I think what you're highlighting, Tobias, is like the data engineering abstraction tree is very complex. Like if you go ask a data engineer what they have to deal with on a daily basis, they might say anything from like a very low level networking bug to like something very deep in Kubernetes to some credential thing to some Python dependency thing, like they might be living in Python requirement hell, all the way up through like data, like table column schema level data quality issues. Right? And like everything in between there's a lot that can go wrong, and whatever can go wrong will go wrong. I recently sat in on our internal data team's offsite, and they very much modeled a lot of their work as an iceberg, where there's a small amount of things at the tip of the iceberg that like people see, like whether that's a dashboard or a report or a table, and then below the line, like kind of under the surface, there's all of the supporting work that they need to do to keep those dashboards afloat, so to speak. And when we think about where we would like to take the data engineers in the future, we really want folks to just be able to think about the job that they're trying to accomplish. Like in some cases, it might be, hey, I have a data product I want to build that's going to power some product feature, and like not deal with the things they don't want to deal with. Infrastructure management is like the easy one. That's very easy to conceptualize because like data engineers want to write data pipelines, not manage servers. So like we can definitely easily take the server management piece away. But I think there's actually even much more we can do. But to your point, our goal isn't to make it all a black box because we're often dealing with folks that are highly technical, that know the internals of the system very well. So we have to expose the right level of kind of observability and monitoring such that if something does go wrong, people can go do root cause analysis and make sure that it works as quickly and as efficiently as possible. We've actually built a bunch of like kind of intelligence into our commercial product to help with that RCA flow to make it much easier for users and customers. But the general way we think about it, Tobias, is we want data engineers to focus on actually the above, like kind of the above the line things at the tip of the iceberg and offload the below the line kind of under the surface things to us as a vendor and partner, such that they can focus on the high leverage activity and not worry about the undifferentiated heavy lifting.
You mentioned observability as one of those key capabilities. You recently released the Astro Observe product suite for giving some of that visibility into what is actually happening in your data flows, what are the alerts that you need to be aware of. I'm curious how you think about the golden signals, if you were, of what are the things that are actually useful? How do you address the signals noise ratio that is always a tricky balance to manage, and some of the ways that you guide your customers into the pit of success, as it were?
So maybe I can just give some context on like why we built Astro Observe to begin with as a starting point. So historically, I mean, we've always been kind of the Airflow company, and we run Airflow for a lot of really good customers. I mean, read about a bunch of them on our website, but everyone from Marriott to the Texas Rangers and everybody in between. And one of the things that we observed as we started to get really deep with all of those kind of customers that were using us to run their Airflow is that every single one of them had cobbled together a house of cards to support data product reliability in some way. There was like a mess of data quality tooling, data lineage and observability tooling, third-party alerting systems, and data cataloging that people were kind of duct tape and chewing gumming together, so to speak, to actually like sleep well at night and understand that the table that they care about is going to be up to date in the morning in the way that they think it's going to be up to date in the morning and of high quality and all that good stuff. It even got as extreme as like working with one of our really big customers on a system that they had rolled out internally to like checkpoint all of their airflow DAGs to make sure that like if anywhere in the process was delayed in some way, they would be alerted immediately. Like they would channel their whole data engineering channel in Slack and let them know, hey, like this checkpoint ran a minute later than it was supposed to. Like everybody drop what you're doing and look into this right now. And there are a bunch of different examples of kind of how folks have built out those stacks in a very fragile way. So when we started thinking about how we could add incremental value to our customers and started getting a lot of feedback from folks, a lot of the asks were around better observability. Hey, we don't want to have these third-party data observability, lineage, and alerting tools just to make sure that our tables are delivered on time and at a high quality. So Astro Observe's first kind of toe in the water is for Airflow users, we want you to be able to have all of the Airflow-centric data observability and data quality tooling that you need to ensure that all of the important data products that you're working on are delivered on time and at a high quality. One of the great things about Astro Observe is you can use it whether you're running Airflow with Astronomer or not. So if you're an open source user and you just want better data lineage across your Airflow DAGs and Airflow deployments, or you want better alerting abstractions on top of your data quality metrics, you can plug right in. It's very easy to get started with. But this kind of allows us to extend beyond purely just managing Airflow for customers and kind of just taking care of that infrastructure management problem. And now talking more about how do we actually help you with those above the line things that you're worrying about every day, and making sure that you're getting a lot of really great value on top of just the pure Airflow management layer at the observability layer. So that was a lot of what kind of spawned the project. And where we're really excited to take it is we're rolling out what we call an insights engine into Astro Observe. Because of that complexity in the data engineering abstraction tree, a lot can go wrong. And there's a lot we can proactively recommend customers do based on signals that we see. One example is if we see like an Airflow task that has a high standard deviation in its runtime, that signals to us that that might be like the weak link in the chain, and it might put your downstream asset at risk. We can give you an insight that says, hey, there's a high standard deviation in this task runtime. You should probably do these things at the compute level to actually tweak your execution pattern so that that's a little bit more consistent. But it also gets even more advanced than that. We have a bunch of really, really awesome generative AI and large language model stuff running under the hood that does kind of AI-powered root cause analysis there. So if there is a task failure somewhere in the lineage graph, we can tell you exactly what went wrong and where and what to do about it. So we're pretty excited about this. We already have some great customers using it, and we'd love to talk to anybody that is out there that is interested in better observability for their Airflow.
Observability also can be very narrow and focused, in this case on Airflow specifically. It can also be very broad, where you need to know what is happening across my entire suite of systems and services, both from front-end applications to back-end data warehousing to my orchestration engine to my business intelligence. And there are a large number of different observability tools across those different problem domains, and numerous just in the data ops and data observability domain specifically. And so I'm curious how you think about the role of Astro Observe in the broader case of data observability, and maybe some of the ways that you are able to either hook into those other systems so that people don't have to pick one or the other, and also maybe some of the ways that you look to provide visibility into the broader scope beyond just Airflow.
Yeah, no, it's a great question. You're right. There are a lot of tools out there. Generally, like we have a very friendly integration strategy. So like if our metadata is valuable to third-party observability tooling, we do tightly integrate there. But where we can deliver, I'd say, differentiated value with Astro Observe is at this intersection of observability and operations, because we're actually running data pipelines and Airflow deployments for a lot of customers. We are able to take that observability data and act on it, rather than just sending you an alert that says, hey, you had a data quality breach or an SLA breach here. We can go be proactive there and say, hey, we're going to scale up the underlying nodes. We're going to give you more memory on this task that failed to guarantee that your table gets delivered on time. So for us, it really is about solving for that intersection between observability and operations, where we can marry the metadata that we get with the actual infrastructure management and kind of task runtime that we manage for our customers. A good example of this is one of the kind of key features of our Observe product is our ability to monitor credit consumption of the underlying data warehouse. So if you're running Snowflake queries or BigQuery queries or Databricks jobs from Airflow, we can actually do cost attribution for you and say, hey, this is how many tasks you have that are actually amounting to this many dollars in Snowflake. And we can see things like table duplication, or if you're running a bunch of jobs that are producing tables that are not consumed by downstream parties, and we can take action on your behalf if you would like us to, that can actually just save you money on the underlying compute layer. So this is the type of thing that I think is very interesting to us as we look ahead, really uniting that observability and operations layer.
Beyond observability, beyond abstracting away the infrastructure so that engineers can focus on the data flows that they care about, what are some of the other aspects of the Airflow ecosystem and enhancements to it that you are currently offering through the broader Astro platform, and some of the other ways that you're thinking about evolving it to add even more value to your customers?
Yeah, without maybe giving you too much of like an Astronomer commercial here, like we generally think about our product value in three categories: build, run, and observe. On the build side, we have a bunch of really great developer experience abstractions that make writing, testing, and deploying Airflow codes really nice. We have a CLI tool, we have a full GitHub integration, and we have an in-product IDE as well that allows you to very easily construct and deploy Airflow DAGs and test them as well against the kind of execution backend that we've built. On the run side, we've built this proprietary component in our system called the Astro Hypervisor that actually makes the unit economics of running Airflow at scale much better. So we can auto-scale things much more aggressively. We can look at your DAG schedules and make decisions around what infrastructure should be running at what time, so that you're not running any idle resources and wasting money. And on the observe side, that's kind of what we just talked through, these broader data quality and lineage abstractions for just having more reliable outcomes on your data products. So I hope that's a quick overview. If you want to go in more depth, I'm sure you can learn more at astronomer.io, but I don't want to beat your listeners over the head with an ad here.
Airflow itself has established a fairly substantial ecosystem around it. There are a large number of plugins, tooling. People have invested a lot in their development around and on top of Airflow. With a major version upgrade, there's always some amount of churn in terms of breakage and migration paths. I'm wondering if you can talk to some of the ways that you have tried to mitigate that, and some of the ways that teams who are building on top of Airflow need to be thinking about how to evolve those capabilities, and maybe some of the types of tooling and plugins that are obviated by the improvements in the underlying Airflow framework.
Yeah, it's a great question. So I think, part of the great piece on Airflow 3 that I actually didn't mention earlier is there's a lot of like really great community requested features as well, independently of some of like the more low level architectural changes that we've made. We have things like DAG versioning, brand new UI with dark mode and all the great things that people want to see, a much better backfill interface, and a lot more in there too. So generally, we see a huge appetite from our customers to get to Airflow 3 as quickly as possible. And we have a lot of experience with these major kind of data infrastructure upgrades. We've been doing it for our entire tenure as a company. So when we rolled out Airflow 2, we kind of ran into the same question: how do we make sure that we're well prepared to upgrade the community and upgrade our customers? So there's been a lot of work done in kind of upgrade checks, both on the open source kind of linting side, a lot of like kind of static code analysis stuff built around Rough. And we also have a full like professional services team at Astronomer that helps with like the more critical surgical upgrade processes. As you can imagine, if you're a company like Ford who's using Airflow to train all their self-driving models, like upgrading isn't as easy as just pressing a button and hoping it works. Like it's a pretty surgical process, and we're very well equipped to do so. So I think the short of it, Tobias, is people really want to upgrade to Airflow 3 because of these long-awaited features and a lot of the great stuff coming in the release. There's a bunch of open source technology that will help with some of the more basic upgrade checks. And if you have kind of a big system upgrade, we have a lot of expertise in-house that can help out with that.
And as you have been building and growing and maintaining and contributing to the Airflow project and community and the Astro platform and product, what are some of the most interesting or innovative or unexpected ways that you've seen that combination applied?
Yeah, as I mentioned earlier, when we started the company, we were working on a lot of dashboards. Like we would be doing a lot of services projects to do reporting. And as we've just matured and gotten in front of more customers, like use cases can tend to surprise us. The Texas Rangers use us to do a bunch of low latency in-game analytics. They actually used us the season they won the World Series, which was pretty incredible. They had my co-founder and a few of our team members down to their ballpark last spring and like let us try on the rings and everything, which was a pretty special experience. But they look at like hitter and pitcher mechanics to predict how the batters should think about going after the pitchers in the next inning and how they should be positioning their infielders and outfielders. It's like definitely like a very cool consumer oriented. I'm also a big baseball fan, so like that was a cool one for me. Use of data. Another really large customer of ours, who I unfortunately can't name, told us recently though that they're running their payroll on Astronomer via Airflow DAGs. Payroll, I suppose, especially in a company with variable compensation models, is in itself a data product. So that's like, a very critical thing that is much bigger than just a dashboard. This is one of the amazing things about building infrastructure companies, honestly, because you build this platform that has all of these very programmable interfaces on top, and then people very much surprise you with what they do with it. They see a very flexible orchestration engine for taking complex interdependent Python jobs and deploying them at scale. And they say, oh, wow, there's a lot you can do with this, right? Like, so as we continue to extend the platform, I'm just so excited to see what else we can extend to. One other one that actually came up last week with another customer of ours was folks that are using LLMs to seed a bunch of their community forums. So they have a bunch of kind of equivalents of subreddits on their platform. And every Monday morning, their community team shows up to work and has a bunch of suggestions for like seeded conversations in their subreddit equivalents that are all generated via LLMs that are taking in a bunch of historical context from discussion on these threads in the past week and saying, hey, this is something that's likely to get engagement. Do you accept it or do you decline it? And that's actually allowed them to get much more efficiency out of the team and just do a lot of content production that's at actually a very high quality. The level of quality that these LLMs are able to produce is really kind of astounding. So as we look ahead and think about what can folks do at the intersections of large language models and Airflow, that's where things get really interesting to us and exciting.
As well as being able to use those large language models to ask what is happening in my Airflow and why did it do that?
Of course, yeah. I think that's table stakes, but yes.
And as you have been building the company, building the ecosystem and community, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
Yeah, I have so many that I could share here. Like, I feel like this could be a podcast episode in and of itself. I don't think it would like cater to the data engineering podcast audience necessarily, but I think a lot of companies are really in the midst of this big kind of push for tooling rationalization right now. And I think earlier in the Astronomer lifecycle, I'm an optimist. I think to be an entrepreneur, you have to be a bit of an optimist. I very much, believed that a lot of the tools and really awesome ideas and companies that entrepreneurs were seeding were going to have a place in the market, and that there were going to be big enough markets for all of these tools to really go build good businesses in. And what we're seeing in the market and hearing from our customers is that likely isn't the case, as a bunch of buyers and teams are pushing to rationalize their spend and stacks and finding that there's a big difference between the tools that are P0, i.e. if they shut down tomorrow, like very bad things happen. Like it's a very critical thing. Someone like gets fired, whatever. And P1 tools that if they shut down tomorrow, maybe it's an annoyance, but there's not like a huge problem for the company. And what we're hearing from a lot of our customers is those P1 tools, there's a lot of scrutiny of whether or not they're required anymore. Do we need this thing? If it goes away tomorrow, how bad is it really? And is it redundant to functionality that we're getting from the core platform? So I think one of my big learnings is people's buying patterns and technology usage patterns normalize on a long enough timeline. And generally, there's an appetite to simplify. Like everybody wants to kind of try to decrease the entropy of the universe on a long enough timeline. I mean, I think it's to be determined how effective that is, but we certainly feel that inside of our customer base, and a lot of kind of what's happening in this broader data ops market and the consolidation of these subcategories is going to be a big thing to watch over the next year or two.
As we've mentioned, there is a broad range of options for data orchestration, how to build your data platform. Everything in the data ecosystem wants to own its own little piece of orchestration, from dbt Cloud to Airbyte to Snowflake to every other system that you can imagine. What are the cases where, for people who are trying to design their systems, you would advocate that Astro or Airflow is not the right choice, and maybe they should just use their built-in orchestration for that platform or some other framework to suit their needs?
Yeah, I think like if all of your orchestration needs are quote unquote local, it's a really good idea to start there. Like very commonly, we have folks coming to us that have started by building a 5-tran or airbyte ingestion process and then a bunch of DBT models. And what they realize is they need broader state management across the entire lifecycle. So for us, that's very much an integration story. Like we use Airflow in tandem with 5-tran and in tandem with DBT, because then you have kind of that broader observability and state management across the entire lifecycle. That's actually like a very small example. The reality of enterprise data ecosystems is that they are very messy. You talk about entropy, like the entropy of enterprise data ecosystems grows faster than the entropy of the universe in many ways. I was looking at our own data catalog recently. Our it's very small 5-person data team at Astronomer has a data catalog with 13,000 assets in it. And it's like, that is the type of scale that we're talking about as we get into a lot of these discussions. And it's not just limited to their next generation Snowflake or Databricks kind of lakehouse architecture. There's all of this legacy all of these legacy services that need some broader integration into the next generation strategy, whether they're running on premise in a SQL Server instance or in Hadoop. The reality of most enterprise data ecosystems is local orchestration is often just not an option. But I will say, if you're starting a entirely new cloud native greenfield project and all you need to do is transform some tables in Snowflake, then local orchestration there actually is a great option and a great place to start. Airflow really and kind of this broader, I'd say, horizontal orchestration comes in when you are starting to deal with a little bit more complexity in the data stack. Same thing with a tool like Airbyte or 5-tran on the ingestion side. If all you need to do is take your Salesforce customer object and replicate it to your Snowflake instance every night, that's a really great option and a really great place to start. Now, where it gets complex is when you need to figure out how to enrich that data with data from servers that you have living in your Hadoop ecosystem. That's where I think we see a lot of data teams leaning into Airflow as the right answer. So I hope that answers your question. Generally, I do think that there's a place for these purpose-built orchestrators in their local context. And where we see Airflow and Astronomer playing is as a very strong partner and integrator into those kind of subcategories.
And as you continue to build and grow and evolve the Astronomer product suite and contribute to the Airflow project and ecosystem, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
Yeah, I think the way in which LLMs disrupt data engineering workflows is so fascinating to us. Because I think we're certainly there's no question that there was a huge hype cycle over the last, 2 years around LLMs, because everybody starts to piece together how they're going to change the future of our work. I mean, I can speak for myself. I use tools like Claude and ChatGPT every single day in my daily workflow at this point. That is a fundamental platform shift that changes the way that I interact with technology as a PM and product leader. Now, the same thing has obviously happened with software engineers as well. Tools like Cursor have taken the market by storm, and Cursor is incredible. I use it when I can and when I get some free time to write some code. Now, I think data engineering is really interesting because what we found from surveying all of our customers is that in data engineering, what we call context really matters in a way that it doesn't necessarily for software engineering applications. Just for example, it's only you don't get that much value out of just going to GPT-4 and saying, hey, write me an Airflow DAG, does some modeling in Snowflake, which it certainly can do. It can produce you a fine Airflow DAG that gives you some boilerplate to work around with. But the challenge is that's decoupled from the context of the rest of your data platform. What is the Snowflake schema that I'm supposed to be working in per the guardrails of my organization? What really does that upstream object look like for me personally? So in data work, it's so broad and it spans so many systems. So the context of how your organization has determined it wants to work with these systems is super important for the model to know. And I think the gap between data engineers today using tools like ChatGPT or Claude to generate data pipelines and remove boilerplate kind of authoring, and the next generation is making sure the models have access to the data platform's context, all of its connections, all of the custom patterns that you've built to interact with these systems, all of the guardrails that you've embedded in those patterns. And Airflow, those take the form often of what are called custom operators, where people hard code certain parameters that say hey, this is how you must interact with the system. You must upload documentation here, here, and here, etc. And that's really exciting and interesting to us because at Astronomer, naturally, we have that context. We have all of the metadata that we need to feed models to make informed decisions about how they should be recommending data engineers interact with the platform. But that's kind of the next big focus for us. And we very much view that as the next big kind of transformation in the data engineering community. So
You mentioned a couple of times already your own internal data team, your own internal data catalog. And I think one of the things I forgot to ask about earlier is what are some of the interesting ways that you are dogfooding your own product or some of the useful lessons that you've learned in that process?
Yeah, we use Airflow for everything, as you can imagine. So like even things that maybe you might not traditionally think you should use Airflow for, we're using Airflow for it. One of the really cool things that we did in the last year was we actually started embedding some of our Snowflake tables in our product as a feature. So we have kind of a dashboarding tab in our product that you can go get a bunch of really interesting metadata about how your organization is operating with Airflow. Because a lot of our customers are running Airflow across many teams. So having a bunch of centralized metadata on like how are these 50 teams operating, what are the most commonly used operators, who's spending the most money, who is actually has the most users deploying every day. That's all like analytics data that we have in Snowflake. And what we've done is via our partnership with the guys at Sigma, have embedded those dashboards directly into our product. That actually, and those dashboards are naturally, those tables are loaded every day by our own internal Airflow DAGs, of course. That actually created a really interesting cultural shift inside of Astronomer because all of a sudden our data team went from being only accountable for dashboards and reporting and maybe more operational data use cases to having a product SLA. So like if the DAGs failed, like we were violating our own SLA, like 3 nines commitment to our customers, and they were on call, like they were going to get paged. And I think we've seen like a lot of that happen with data teams over the last couple of years, where as the use cases for these pipelines have shifted, the requirements and roles and responsibilities of the data professionals have also shifted. One of my co-founder Viraj used to say that the DAG is the new microservice in some way. All of a sudden, these data pipelines are microservices in our core applications, not just kind of back office reporting pipelines that are doing different kinds of things. So that was a really interesting use case for us, mostly because of how it changed our culture and how it changed our own internal expectations of our data team. And it's been really fun to find more of those too. Like our product now is powered by many different DAGs, and we kind of have a whole dedicated production server running the stuff that powers our product and customer facing features, and that's been pretty cool. So
are there any other aspects of the work that you're doing at Astro, the work that you're doing to contribute to and support the Airflow community and ecosystem, and just the overall space of data orchestration that we didn't discuss yet that you'd like to cover before we close out the show?
no, my reaction is we touched it all. If I think of anything, I'll definitely shoot you a note, Tobias. This has been super fun. Appreciate you having me on, and always fun to talk about data engineering and Airflow with an awesome community member. I'm a big fan of the podcast too, long-time listener. So
thank you. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Look, I think the biggest gap is kind of how disjointed it all is, honestly. And again, people have adopted so many different kinds of tools and point solutions for this whole kind of data ops lifecycle. And what we're seeing from our customers is they don't want to do that, right? We very much believe orchestration is kind of the natural consolidation point for a lot of these tooling adjacencies. Naturally, like that's kind of our worldview. Because of how horizontal it is, it has full access into the full lifecycle across the enterprise. It's not just local to Databricks or Snowflake or ingestion. It's going to be able to tell you everything. Plus, it is the thing actually running these pipelines at the end of the day. So actually, like kind of that operational lever allows us to do some very interesting things at the intersection of observability and data pipeline management and execution that you're not going to be able to get elsewhere. But I do think that generally one of the biggest problems in the space, especially in the enterprise, is tooling sprawl. And how are we going to actually both simplify and rationalize while creating more value for the end user? I'm actually okay with tooling sprawl if it creates net new value for the end user. But I think we found ourselves in a place where we have a lot of tooling sprawl that is actually detracting and creating worse user experiences for the data engineer. Because if something breaks, the data product has a quality or SLA breach, where do you look? Well, you're now kind of traversing 5 or 6 different systems, from the Kubernetes cluster to whoever your networking provider is, to your kind of data quality tool and table column schema level tool, to your alerting system, to your orchestration system, to Airflow logs. And I think simplifying that is a major opportunity. Just going from actually needing to traverse that abstraction tree to saying, hey, your table is not in the state that you want it to be, because we know what state you want it to be and when you need it to be in that state. Here's exactly what you need to do about it. and pulling away all of the complexity, I think is where this thing needs to go to create net new value. I just think the days of traversing 5 or 6 tools to solve one problem are gone.
And having to build 5 or 6 integrations just to solve that problem in the way that you want it solved. I'm thinking most notably in my own context about authorization and authentication, where you can auth people, but what are the permissions that they're supposed to have, and how do you actually apply that without making yourself insane by writing the same thing in 15 different ways for 5 different systems?
100%. So believe it or not, this is a funny story. I'm a bad engineer at this point. My team actually gives me crap whenever I try to open up a PR when I get some free time. But I was involved in writing the first version of our hand-rolled auth system. This was prior to really leaning into Okta and Auth0 for just about everything. And the level of complexity there is so crazy. And it's mind-boggling. So I think that's actually a good comparison and analogy.
All right. Well, thank you very much for taking the time today to join me and share the work that you're doing on Astronomer and Astro and your contributions to the Airflow community. It's definitely a very useful and important member of the overall data ecosystem. So we appreciate the time and effort that you and your team are putting into keeping it healthy and vibrant. And I hope you enjoy the rest of your day.
Thanks so much, Tobias. Appreciate you having me on.
Thank you for listening, and don't forget to check out our other shows. Podcast.init covers the Python language, its community, and the innovative ways it is being used. And the AI Engineering Podcast is your guide to the fast-moving world of building AI systems. Visit the site to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story.
And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.